Hello. Well, last problem on this section. We're almost done the whole chapter. The last problem, again, another problem that tends to make people stumble and fall. And so I want to show you how to do that. So let's go into the problem, example 5. Okay, example 5, it says the figure JKLMN is the, and we all have primes on it, so that's the image, is a dilation of the figure JKLMN, which is the pre-image. So we start with JKLM, find the coordinates of J prime, M prime. Okay, we know K, L, and N already. And it looks like, if I just get my pointer here, I would love to just do I would love to just go ahead and assume it's the center of the dilation is at 0, 0 and do a scale factor, but that's not always the case. So we have to check that the center is there. So let me find it right here. Okay, so first of all, we know that to go from here to here you have to go down 3, right 1, left 1, down 3, left 1 to get another point, down 3, left 1. So what we're saying is the dilation has to, the center of the dilation has to be somewhere along here. Okay? We'll do the same thing with K to K prime. We know we have to go down 3, right 3, down 3, right 3. So we're going to connect those points, and we already know where the center of the dilation is. It turns out it's somewhere right there. It actually turns out to be at, looks like 2, comma, -1. So we'll put the center at 2, comma, -1. Okay. Well, that's a real problem because that's not 0, 0. We don't have a nice way to do that. Well, let's check one more here. We know N and N prime here. Well, you just have to go up 4 and then go up another 4. And yes, that just reconfirms that we know where the center is. This is the center. Okay? Now, we need to go from here to here. And you'll notice here we did 2 steps. 2 steps of right 1, up 3, right 1, up 3, and 2 steps of right, excuse me, left 3, or going -3 direction, and up 3. And we did 2 steps there. We also know that the next one, let's do M here. That looks easy because it looks like it's straight across. We can go straight across here. Now we know we did 2 steps, so we kind of have to cut it in half. So let's do that again. 1, 2, 3, 4, 5, 6, 7, 8. What's half of 8? 1, 2, 3, 4. And that's where I think M prime is. And it looks like it's at 6, -1. And that one's easy because we are horizontal from it. Completely horizontal from it. And since we have 2 steps, there's our 2 steps. Remember here we had 2 steps. We had 4 and 4. So let's do the same thing here. We need to go across, we need to go here, and we need to go right. Looks like 1, 2, 3, 4, 5, 6, and up 2. And we're going to get, so let's just do half of that. Because we know we need 2 steps, so we're going to go half of 6 right here. And then we went up 2, so we're going to go up half of that. And we're right there. We can check. That looks like it. There it is right there. There's your 2 steps. So there's J prime. It's kind of messy there, so I'm going to write J prime. Looks like it's -1, -2. -1 in the X, -2 in the Y. So that was one way to do it. Remember, they all have to have the same center point, so you really need to see where that center point is, then you can guess where the other ones are, and we got lucky on the horizontal. But you can just do this rise and run and steps, and you can take any big set of steps and break it up into the number that you need to get there. So that's the end of the example 5. Again, it's a tricky problem for a lot of people, but the method isn't that hard if you use steps and slope and make sure you find your center so you know where your other steps, your missing steps are going to be. Hope that helped.